Many decades ago, I worked as a wildland firefighter for the U.S. Forest Service to earn money for college. In those days, the fire season on the Angeles National Forest, where I was a crew member on the Big Dalton Canyon engine, started in June and ended when the first inch and a half of rainfall was recorded. In those days, a 25,000-acre fire was considered big, and a million-acre fire was a once-in-a-century event. And in that era, it was rare for a wildfire to burn aggressively at night, giving crews the opportunity to establish and extend control lines. Today, with climate change, it's not unusual for a wildfire to burn 25,000 acres or more in a day, and million-acre fires burn every year. And in many parts of the world, the fire season now is all year long. Also, in the last few decades, nighttime fire behavior has become much more aggressive in several parts of the world, making the job of wildland firefighters more dangerous and more difficult. In this video, I will explain why this is happening. But before continuing, if you have not done so already, I would appreciate it greatly if you would subscribe to my YouTube channel. In a recent research paper published in the journal Nature, Balch and al. Document the growth in both the number and size of worldwide wildfires in the last 2 decades. They note that in addition to more daytime wildfires occurring, there has been significant growth in nighttime wildfire activity. They find that these increases are connected to climate change-driven increases in vapor pressure deficits at night. Now, most likely you've never heard the term vapor pressure deficit before, so let me explain what that means. The amount of water vapor in the atmosphere varies depending on weather conditions, and typically weather reports give an indication of how much water vapor is in the air by noting either the relative humidity in percent or the dew point, the temperature at which the water vapor in the air condenses out. Now, water vapor in the air adds to the weight of the air, and that in turn adds to the pressure on the Earth's surface. That additional pressure from the water vapor is referred to as the vapor pressure, and it can be measured in pressure units, just like you measure the air pressure in a tire. Those units are pounds per square inch, for example. We also know that at any given temperature, there's a limit to how much water vapor the air can contain. When the air contains the maximum amount of water vapor for that particular temperature, we say that the air is saturated, or that the humidity is 100%. The corresponding vapor pressure on the ground then is referred to as the saturation vapor pressure. Now, when the humidity is less than 100%, the vapor pressure from the water in the air will be lower. It will be the saturation vapor pressure multiplied by the relative humidity in percent divided by 100. The vapor pressure deficit is just the difference between the saturation vapor pressure and the actual vapor pressure of the air. So the vapor pressure deficit is just another way of measuring how wet the air is and how much pressure it's exerting on the ground. A large vapor pressure deficit corresponds to very dry air, while a small vapor pressure deficit corresponds to very humid air. When the vapor pressure deficit is large, evaporation from vegetation will be high, leading to low vegetation moisture, producing conditions very ripe for wildfire growth. When the vapor pressure deficit is small, evaporation from vegetation will be low. If the vapor pressure deficit becomes small enough, the probability of ignition drops essentially to 0. When that happens, firefighters say that the wildfire is lying down, and that makes it easier for them to contain it. Let's talk about fire weather in more detail. To most people, the term fire weather implies hot, dry, and often windy days. Since we know that warm air can hold more moisture than cool air, the saturation vapor pressure is higher on hot days. But during fire weather with very low humidity, the actual vapor pressure of the air drops to a low value. Since the vapor pressure deficit is just the difference between the saturation pressure and the actual vapor pressure, the vapor pressure deficit becomes very large on hot, dry days. Under these conditions, moisture readily evaporates from vegetation, and all it can take is one spark to set off a wildfire. At night on very dry days, the temperature usually drops significantly once the sun goes down, and the relative humidity also usually rises much. This produces a much smaller vapor pressure deficit, and if that deficit becomes small enough, that's when the fire will lie down and become easier to contain. But one of the consequences of climate change is that the temperature doesn't drop as much at night. In fact, in the recent past, average nighttime temperatures have been rising faster than average daytime temperatures. Thus, we now are experiencing more nights when the temperature doesn't drop low enough for the vapor pressure deficit to become small enough to inhibit ignition. When that happens, the fire does not lie down at night, it just keeps growing. And figures A and B on this slide show that. They're from two different fires. The top one is from the Snowy Complex fire that happened in Australia, and the bottom one is from the Tubbs fire in California. Excuse me. The red dots show daytime ignitions, and the blue dots show nighttime ignitions. And for both of these fires, there was substantial fire growth taking place after dark. For at least the last 40 years, nighttime temperatures have been rising faster than daytime temperatures because of climate change. This has increased the number of nights when the vapor pressure deficit exceeds the threshold needed to prevent wildfire growth. And this figure, also from the Balch paper, it shows that the areas where the increases in nighttime hours when ignition is possible far exceed the areas where there has been a decrease. The darker the image, the greater the increase in nighttime temperature deficits. In parts of Western North America, this amounts to more than 11 nights per year when significant nighttime fire growth is possible. This climate change-driven worsening of wildfire behavior, combined with weather conditions that produce strong winds, explains why wildfires have become so much more difficult to contain and so much more dangerous for the men and women working on the fire lines. I hope you now understand why wildfires have been growing so rapidly in recent years. If you have any questions, don't hesitate to ask them in the comments section, and I'll do my best to answer them. Thanks again for watching this video. Please share it with friends and family, and especially with any firefighters that you may know. And if you haven't done so already, I would appreciate it greatly if you would subscribe to my YouTube channel. Just click on my picture in the circle below to subscribe.